As we move into Chapter 6, you're going to see a lot of the titles say solving systems. Now before we move on, let's make sure that you understand what it means to solve a system. In order to solve a system, at least in our case right now, we're going to have two variables. Typically those variables are going to be x and y. And because we have two variables, we're also going to have two equations. Now, the goal of solving systems is to find out when these two variables will equal the same thing in these two equations. So we're going to write down when x and y, or what other variables you may have, are going to be the same for both equations. Let's move on and take a look at we're going to take a look at some vocab, and then we're going to move on and try to apply some of this. Today, you are going to learn how to solve by graphing. Well, it was very helpful that we just did that Chapter 4, Chapter 5 packet, because we went over how to graph straight lines. But now you're going to see two lines on a graph, and we're going to see where the two lines intersect. Where the two lines intersect is going to be your solution to the system. System of linear equations is when you have two or more, no doubt linear, which just means a straight line, you know the word line is in linear, equations together in a problem. The solution to a system of linear equations is what we say an ordered pair, which you are used to, right? An x comma y, ordered pair that fits both equations. We are going to write our answers as an ordered pair x comma y, or if you're using other letters, you put them in alphabetical order as an ordered pair. The warm-up problem I'd like to do with you in class when we get here. You can try it at home, and then when we can you come in and we can discuss it. Now today I already told you you're going to solve by graphing. Tomorrow you're going to solve a different way, okay? This is very convenient, but you need to find the most convenient way to graph. Typically, guys, y equals mx plus b is the most familiar way of graphing. To me, it's the easiest way of graphing, and it's just pretty good, all right? You're going to see where your lines meet, or the math word intersect. You might need to go left and right in order to find this. This spot is the solution, so where they meet is the solution. You are then going to write your solution as a point x comma y. Problem 1. What is the solution of the system? Use a graph. I have 1, 2 equations. Now it might be helpful for you to pause the video and get another colored pencil or another colored pen or something like that, okay? Number 1 I'll do in pencil, number 2 I'll do in pen. Number 1, y equals x plus 2, and number 2, y equals 3x minus 2. Something to note about both of these is that they are both already set equal to y. Well, that's going to help us with y equals mx plus b. In number 1, the y-intercept, or the b, is 2, positive 2 because of the positive 2 in the back. The slope is the number in front of x. Don't tell me that number is a 0. That number is a hidden 1. So your slope is 1 over 1. Now we're going to move on to the second equation. If you don't mind, I'm going to actually list the slope first. I'd rather have done that over here, but it's fine. It's the same answer. The slope in this problem is a positive 3 over 1 because it is the number in front of x. Remember how it's mx plus b? The y-intercept in this problem is a negative 2. Now it's time to graph both of these equations. The first equation, you plot the y-intercept first, so go to positive 2 and make a dot. And then you use your slope to rise and to run. Rise, run. Okay? So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, all the way into the end of my graph. A lot of people stop there, but I will encourage you on your first equation to also do the exact opposite. Down 1, left 1, down 1, left 1, down 1, left 1, so on and so forth. Now you might be asking me, take a straight edge and connect. You might be asking me, why do you do all the ones on the left, Mrs. Langeli? Why is that important or helpful? The reason that's important, or maybe helpful, is because when I graph my second line, they may meet down here. And if you didn't plot these points, and you're not very good at keeping up making straight lines, and especially if you won't use a straight edge, if you don't have those specific points, it's going to be very hard for you to see where these lines meet. Second equation, start with your y-intercept by graphing negative 2. Use your slope to rise and to run. Rise 3, run 1. 1, 2, 3, right 1. 1, 2, 3, right 1. You should notice at this point that I just circled, since I went up 3 and I went right 1 each time, that they meet. Something important to note is when I use my slope, you always use your slope from your y-intercept. So remember my y-intercept was -2? I use my slope 3 over 1. I put my pencil on my original -2, and that's where I go over 3 up 3 over 1. Some people think that you start from the origin no matter what. No, your slope always goes from your y-intercept. So I'm going to grab the straight edge and connect the blue line. You can see on the blue line that it perfectly matches up with the pencil line. Do you see where they meet? That is your solution. Do not assume that that's good enough for me. I need to know that you know your answer is the ordered pair over 2 up 4. And that is the x and the y value in which both of these equations will be equal. In other words, if you take 2 and plug it in for x on the top equation, you will get 4 for y. If you take 2 and plug it into the bottom equation, you will get 4 for y. And that is the only point in which that is true. Moving on to the second part of number 1, the got it part. If you'd like to pause the video, you can do that and try it on your own. I'm going to walk through the rest, so go ahead and make your decision if you want to pause the video and try it on your own and fix it if need be, or if you just want to go ahead and keep with me. Number 1 and number 2. Our goal is to see what the solution is, so we need to graph them to figure out where they meet or intersect. Number 1, y equals 2x plus 4, and number 2, y equals x plus 2. Realizing that these are ready to graph because they are in the form y equals mx plus b, I'm ready to move on. The slope in number 1 is 2 over 1 because you always want it to be a fraction, and the y-intercept is a 4. In number 2, the slope is a 1 and the y-intercept is a positive 2. Remember, it's a 1 for the slope because of the 1 in front of the x. Make it a fraction, 1 over 1. Let's plot the first equation. Well, first, go up 4, make a dot. From that point, rise 2 and go to the right 1. Remember, I told you I find it very beneficial if you do the exact opposite as well. Down 2, left 1, down 2, left 1, down 2, left 1 until you reach the end of the graph. The reason doing this is okay is because if you are going down and left, you are going negative and negative. And I'm hoping that you know a negative and a negative makes a positive. So by going down and left, you're not changing your slope, you're just kind of adjusting it. Okay? Put your arrows on the end to make sure you know that it indicates it goes on forever. Now for the blue equation. You're going to go up to positive 2 and make a dot. Rise 1, right 1, rise 1, right 1, that's a mouthful, rise 1, right 1, and remember to go down and to the left, down and to the left. Look where they meet. They definitely do have a significant meeting point. The 2 dots come together. Once you find that those 2 dots come together, you can stop. You don't have to continue that line because guess what? You found your answer. Make your line, put arrows on to indicate that you know lines go on forever into both directions, and write your answer as an ordered pair. Your answer to this problem for the x value happens at -2. Your answer to the y value happens at 0. And again, if you plug -2 in for x, you would get out 0 for y on both equations. Problem number 2 is an application problem. You're going to see a lot of application problems on the Keystone, so you may as well just get used to it and learn to deal with them. Problem 2, writing a system. Now the reason this is writing a system is because not only they're giving you information, but unlike problem 1, they don't give you the equations. You have to make them yourself. So biology, scientists have studied the weights of 2 alligators over a period of 12 months. Okay, so from the time they were born until the time they were a year old. The initial weight and growth rate of each alligator is shown below. Okay, alligator 1, alligator 2. After how many months Did the alligators weigh the same? Well, we can do this. Alligator 1, the initial weight when it was born was 4 pounds. The growth rate is the change of 1.5 per month. Alligator 2, initial weight of 6. The change is 1 pound a month. Now the reason I'm saying that word change, kind of annoyingly, is because when you see the word change or rate of growth, that's simply a slope they're telling you. That's what slope is, guys. Slope is a rate. Slope is a change, okay? So alligator number 1, I like starting things with y equals if possible. This one is. The initial weight is 4 pounds. So I like to put that initial weight in the back. The growth rate is 1.5 for every month. Since it's the one that's varying, you put it with the variable. Now let's talk about alligator 2. The initial weight is 6. So 6 is what's going to be my y-intercept. The rate of growth is 1. So that's going to be my slope. Since the rate of growth 1 is what's varying, I put it with my variable. You guys have seen this kind of problem when we did our review packets and we were talking about, like we were even talking about cell phone plans. We were talking about the charge per minute and like the basic plan. This is exactly on the same lines. It's just, I guess, with alligators. Okay. The slope on alligator number 1 is 1.5. The y-intercept is 4. I'm going to talk about this 1.5 in a minute. Let's move on though to alligator number 2. The slope is 1 over 1 because I like it to be a fraction. And the y-intercept is 6. Now this 1.5, you really don't want your slope to be a decimal. So 1.5 is 3 over 2. Because isn't 3 divided by 2 1.5? So we're going to note this as the slope. It's going to be better for us when we go to graph. Please be very careful when you look at this graph because this graph skips by 2 on the y-axis. That's going to we got to be careful when we go to graph, all right? I'd like to make another note. We use the variables y and x because we're familiar with them. But for this particular problem, instead of y, they want us to use w to represent the weight. And instead of x, they really would like us to use t to stand for time. So if we want to rewrite our equations to make them happy, let's just do that, okay? So on the second alligator, w is going to be 1 times t plus 6. Sometimes we get in the habit of always using x and y, and that's not wrong, but it's also good sometimes to use variables that help us relate to the problem. That way when you look at it, you could say, oh, the weight is 1 times the time plus 6, okay? They just kind of help us identify. Let's graph the first alligator. Start at 4 and make a dot. Remembering that your slope is 3 over 2, you might want to watch this very careful. Do I have your attention? You're going to rise 3 and run 2. So you see where my pencil is? Don't forget it skips by 2 here. 1, 2, 3. See how I did that? 1, 2, 3. Remember, because it skips by 2. 1, 2. The x-axis does not. So by rising by 3, just remember I have to go 5, 6, 7. Right there. Over 2. 1, 2, 3. Over 2. Watch again. 1, 2, 3. Over 2. 1, 2, 3. Over 2. And I now have alligator 1 charted properly. Now you have to be real careful because that y-axis is a little goofy. And you never know, I mean that could very well happen on the keystone. They expect you to be able to skip properly on your y-axis and use your slope accordingly. And who knows how your alligator is going to grow, but we're just going to pretend that they grow forever, okay? Put it as a line. Alright, alligator number 2. Start at 6, make your dot. Your slope is over 1, up 1, over 1, up 1. Or excuse me, up 1, over 1, up 1, over 1. Ready? Up 1, over 1. Up 1, over 1. Ah, there's the over 1. Ooh, I don't want to get white out. Okay. Up 1, over 1. It hasn't touched yet. Up 1, over 1. Yay! We found the point in which they meet. We can now connect our line. Alright, ignore that little dot. I obviously made a mistake. That happens. Ready? Whee! So we can see that alligator number 2, while he does start bigger, he catches up pretty fast to alligator number 1. And he catches up at month 4 and at a weight of 10. So here's what we're going to do. We're going to write 410 as our answer, but because it's a word problem, we're going to state it as a final answer. The 4 represents time. It's on the time axis. And the 10 represents the weight. So let's write it as a sentence. In 4 months, they will both be 10 pounds. And there is a beautiful answer for a beautiful word problem. Everything else is going to be on the next video.